Good afternoon, students. Am I audible?
Yes, ma'am.
Okay. In yesterday's class, we completed hashing techniques. So, any doubt with respect to the topics what we discussed the previous classes? So, today is going to be the revision class of Unit 4. So, in Unit 4, we have two major topics. Screen is visible. So, we have trees and hashing techniques. With respect to trees, we discussed how the tree comes under linear and non-linear data structures, and general trees, binary tree, binary search tree, AVL tree, B tree, then expression tree, decision tree, and red black trees, Splay trees. Based on the same topics, we have two lab experiments in your syllabus: binary search tree implementation and binary tree traversal implementation. Then we started with the topic hashing. We have three major subheadings under hashing: introduction to hashing, hashing functions, and methods of hashing, how to resolve the collision in hashing. So any doubt with respect to those topics? We saw what is a tree and how it is related to our real life scenario, definition and explanation. What are the terms, keywords associated with the tree while creating a tree structure? What are all the parameters of a tree? So a tree can be represented as an T, and it's having root, it must have root node, and the root node will be the parent node. The root node will not have any other, it's not having any parent. And the nodes which are inherited from root are called child nodes. And if the child is leaf node, it won't have any other child. And within the tree structure, we have the following keywords and relationships among the various attributes. We have the parameter called external node. The nodes which are in the leaf nodes are called external nodes. And internal nodes means if a node is having branches or children, then it is an internal node. Ascender node, descender node, ordered. The tree is ordered if the elements are placed in a particular order. Path of any two nodes, how we are reaching the from source to destination in a tree, from one node to another node using which path. And the root of the tree, parent node, the root node is a parent node, as well as the nodes which are having children are called parent nodes or internal nodes. Child nodes are, if it is having any parent, then it is child node. Within a tree we can have a number of subtrees, and visiting all the nodes in a tree is called tree traversal. Levels of the tree. So we have the levels of the tree. We will start from root node. The root node is in level 0. The child node will be in level 1. Then grandchild will be in level 2, like that. And the very key is the value which is stored inside the node. Siblings are the nodes which are in the same level, or the children belongs to the same parent. Depth of the tree and height of the tree. So those are the terms associated with the tree structure. Say for example, if you take this particular tree, it's having a root node. Then edge which is connecting the node A and node C is called an edge. The same way, any two different nodes are connected with each other through an edge. And here the depth starts from root node. The root node in depth 0, child node in depth 1, grandchild in depth 2. The leaf nodes are in depth 3. And according to height, we'll start from leaf node to parent root node. So the leaf nodes are in height 0, like ground floor, first floor, second floor. So the parent root node is in height 3 because here we have 4 layers. The indexing starts from 0. The nodes which are not having any children are called leaf nodes. So here also you can easily understand. We have root, edges, the value stored inside the node is called the key, height of the tree. The height starts from 0, 1, 2, 3, from leaf node to root node. So within this node, this particular BDE is a subtree. For this particular subtree, B is the parent node. B is the parent node, and the if you take B as an subtree, B is parent, left child and right child. The node D and E are belongs to the same parent and they are in the same level, so we'll call it as siblings. The level starts from root 1, root 0, level 1. Root node is in level 0, level 1, level 2. Height starts from leaf node to root node. And if you take binary tree means it can have maximum 2 children. Perfect binary tree means all the leaf node will be in the same level and all the parent will be having maximum 2 children and all the left and right childs will have complete leaf nodes. And we discussed other properties of a tree. The root, every tree has a special node. The root node can be used to traverse every node of the tree. It is called root because the tree is originated from the root. And every tree can have a number of vertices or nodes. To connect all the nodes in a tree, we need n minus 1 vertices. If the number of vertices in a tree is more than n minus 1, then that is, if there are n nodes, we need n minus 1 edges. If the nodes are connected with greater than n minus 1 edges means, then it is not a tree. It becomes a graph. Every child has only a single parent. The parents can have multiple children. If they are having maximum 2 children, then it becomes binary tree. And the tree is an abstract data type. And we are calculating the depth and height of the tree based on level 1 to level n. And we can perform the various operations like we can add an element in the root node, left child, right child. We can replace an existing node. We can delete a node and we can attach a node for most of the operations, arithmetic operations like addition, deletion, searching. Each process, each executable statement needs order of 1. Then we discussed the types of trees. Binary tree means binary decimal system. So in the binary number system, we have only two values, 0 and 1. Maximum 2, 0 and 1. So if any tree is having maximum 2 children, then it comes under binary tree concept. The number of nodes in a binary tree will be always 2, and the root node will have left child and right child. Based on the binary tree, we are getting binary search tree. Binary search tree, we follow the constraint. The left child node must be smaller than or equal to or its value of the parent node, and the value of the right child should be always longer than the or equal to its parent. So the left child should be less than the root node and the right child should be greater than the root node, so that we are getting an ordered list: left, root and right, small, greater and greatest. So even in the subtree also the same constraint is implemented. Left is 1, small, greater and greatest. So a binary tree with the, if the values are stored in the left is less, root is greater, the right child node is greatest means then it is called binary search tree. So when you go traverse the nodes in a particular in order traversal, then you will get an sorted list so that we can easily search for any element. When we start the searching process, the nodes, the data should be in already sorted form, especially in binary search. Then we saw the AVL tree. In AVL trees, decent self-balancing binary search tree. AVL means we will perform the AVL rotations. Here we are applying one more constraint. The height of the child of a node differ by at most one. We already discussed what is height. Height is calculated from leaf node to the leaf node is in height 0, height 1, height 2. So height 0, height 1, height 2. So the nodes, the parent and child will have the maximum height difference of 1. If it is not having that balancing, then we need to perform the AVL rotation so that the balancing is implemented. Then we discussed the B trees. A B tree is another self-balancing search tree that comprises many nodes to keep the data stored in a particular order. Each node has over 2 child nodes. Each node comprises of multiple keys. So here, a binary search tree with self-balancing. And here we are adding one more relaxation. A node can have over 2 child. So it can have more than 2 child. So more than 2 child means this particular node is having 1, 2, 3, 4, 5 childs. Here this particular right subtree is right child is having 3 childs. And each child can have n number of keys. So here we have only one key, but here it's having 3 keys, main 3 keys. So why we are using this means, say, yeah, we are creating clusters. Say the values are in single digit from 0 to 10. They are in 20s, 40s, 50s. And here, and anyhow, we need to maintain the binary search tree constraint. Root left child is smaller, root is greater, right is greatest. And here root is smaller, left child is small, and the root node is having greater value, right child is having greater than root node. In n-array tree, it is the maximum number of children a node can have is limited to n. Say for example, if you take a 2-array tree, you can have 2-array tree, 3-array tree like that. Each node in the binary tree has maximum 2 children. A full n-array tree is in which the children of the node is either 0 or n. So here we can group the elements in such a way that we can maintain a particular order. What is the why we are using trees? What is the advantage of using trees means? So it gives you a way of representing the data in a hierarchical form. The tree reflects the data structure connections, how the data are interrelated with each other. The tree is used to represent the hierarchical relationship among the data. It offers an efficient search. So because the data is represented using hierarchical relationship, so it is we can easily perform the addition, subtraction, the various data structure related basic operations like adding, deleting, modifying, updating, displaying, searching. Those processes are less complex compared to other data structures. Say in adding, deleting the elements in a stack, queue, linked list is a tedious process, but here somewhat simple compared to other data structures. The tree has it allows the subtrees to be relocated with minimal effort. Then we discussed what is a tree traversal. Tree traversal means visiting all the nodes in a tree. In general, we will put some constraint. We need to visit all the nodes only once in a particular order, so that and with minimum distance. We have to visit, especially the concept is used in a tree shortest path algorithms, traveling salesman problem. So in that case, our aim is to travel less distance and complete the process. And only once we have to visit. We should not visit any node more than once. And the tree traversal can be performed in three different ways. It may be in order, because we are talking about binary search tree. Binary means maximum two children along with parent. So we will have maximum any subtree we will have. If you go with the recursive procedures, any subtree will have maximum three nodes, left, right, and root node. So with respect to the three major attributes of the tree, like left child, right child, and parent, we can visit the nodes in the in order form, pre-order form, or post-order form. Here in order means the root node will be visited middle, second. And the pre-order means if you visit the root first, then left and right child, that is pre-order. Pre means before, plus I is prefix. And post-order means I plus plus. So first we will visit left and right. Last we will visit root node. Say for example, here if you take the in-order traversal, so the logic will be first visit the left child, then visit the root node, then visit the right child. Again, if you take the subtree, anyhow, the function will be called recursively. In that case, visit the left child, root and right child. So here this particular subtree also left, root and right. So in that way, the nodes will be visited. And if you take pre-order traversal, visit the root node first, then left subtree and right subtree. And post order means left, right, and root. So we'll visit the left child, right child, then root node. So the order will be left child, right child, and root node. So in a binary tree, we have maximum left child, right child, and root node. So we are having only three combinations: pre-order traversal, root left right, and in order means left, root, and right. Post order means left, right, and root. So any doubt with respect to the tree traversal techniques? What is tree? What are the terminologies associated with the tree? And the different types of trees, like general tree, binary search tree, AVL tree, B tree, and NRA tree. Any doubt so far? Then we have one more type called decision tree. So in the decision trees are used to we will represent the data what we have in a tree structure by traversing or taking the choices. We can come to one, if you follow a particular path, we'll come to one conclusion based on the values. Say if you are forecasting the weather, if the day is sunny and it's having humidity, and high humidity is very high or normal, based on we can take one path. So according to that we can predict whether the day is hot or rainy, humidity, wind speed, moisture, all those things. And they are used to take some decision. The same way we can represent the values of an patient, whether he is having headache, fever, cold, cough, yes or no conditions. Then we'll come to a conclusion. What about the lab test, blood test, all those things? We will predict what kind of whether he is having normal fever, viral fever, or typhoid, like that. So the next type is called expression tree. Here we are representing the arithmetic, logical, or relational expressions in a tree structure form. Especially the operators will be mentioned in the root node, so that the operator can be applied on any two operands. So the operands means the variables or constants that will be put inside the child, left child and right child, and the operators will be represented in the root, so that we can take the two operands or variables or constants, the operator will be applied, so that we can evaluate and find out the result. Here this particular tree represents 3 plus 1 multiplied by 3, and 7 minus 4 multiplied by 3 plus 6. so that we can easily evaluate and we will get the this is one expression, another expression, another expression. It is a compound expression. Say for example, the expression 3 plus 5 plus 9 star 2 is represented like this. Say the log of x, the log is in the root, x is here, and factorial is the function that is in the root. Then we discussed the red black trees. Here it is also the red black trees also, they are also by self-balanced binary trees. Here the red black tree also and tree, binary tree as well as AVL tree, binary search tree, all those things are there. Along with those properties, we are adding additional property. We are adding colors to the nodes and we are putting some constraints to the nodes. The black root node should be black in color, and if the root node is black, the child should be in red color. If the child is red color, the grandchild should be again in black color. It means any parent and child nodes should not take the same color. It means the consecutive nodes should not have the same color, and all the child nodes or the leaf nodes will have the link. It's not having any other child, so they are called leaf nodes. They will have the null value. If those properties, colors, the consecutive nodes are having in different colors, and the root node is always a black color, and parent and child will be in different colors, and the leaf nodes will have carry the nil address. It's not having any other link. So then it becomes a red black tree. It is used in special conditions, especially the signal processing, traffic control, where this kind of constraints can be applied in real time scenario. Then we discussed the splay trees. The splay trees are self-adjusting binary search tree. Binary search tree and as well as self-adjusting. Self-adjusting means like AVL tree. So here the tree automatically reorganizes itself, that frequently accessed or inserted elements becomes closer to the root node. So if you are adding or deleting an element from the splay tree, it will adjust itself or it will rotate the nodes by itself so that it can maintain the balance. And how it is rotating the elements means the frequently or most widely used data are placed near to the root or in the root so that the accessing processing time can be saved. Say bringing the most recently accessed or inserted element to the root of the tree by performing the sequence of tree rotations, because it is an AVL special kind of AVL tree, and it's putting like priority queue. We are giving preference to VIPs, elderly people, aged people, or people with a disability. So like that, here also we are giving some preference like priority queues, so that the recently accessed or most widely used data will be kept near to the root or in the root. Say for example, this is our given binary a search tree. If you call the function splay of 2, so here we want to keep the node 2 very near to the root node or in the root node. So we are rotating the nodes in such a way that the node 2 reaches the root node, and once the node 2 becomes root node, we need to self-adjust other nodes so that the binary search tree constraint is maintained. When 2 becomes root node, the left root right should take the corresponding locations. Left should be less than root and right should be greater than the root. So 2 becomes the root node. Then the values which are less than 2 will come in the left child. The values which are greater than 2 will come in the right hand side. So we are moving the other nodes in such a way that the binary search tree constraint 4, 5, 6, left is 4, root is 5, right is 6. So it's again self binary search tree. Again 3, 2, 3, 4, 5, 6. That binary search tree constraint is implemented. So any doubt so far? The trees, general trees, binary search trees, AVL trees, B trees, B plus decision trees, expression trees, red black trees, and splay trees. Tree traversal, in order, pre order, and post order tree traversal. So I will take the attendance from the Zoom recordings. Any doubt? Arnav, the meeting will end in another 1 minute. Any doubt? So you go through the topics of Unit 4, and I will upload 2 materials with respect to Unit 4 today.
Ma'am, do we have to join again?
Yeah, you need not join. You complete the assignment 3, 4. I think today I uploaded one assignment now based on trees and hashing that you complete and upload and complete the project also. I need like to see the demo on Tuesday. So I will take the attendance from the Zoom recording. Go through the topics. If you have, ask me in the next class. Manan Chavan, Manas Chavan, any doubt? So Tuesday, I need the observation. And one, you can complete that hashing program also. It is your last program in the syllabus because the topic is covered. Okay, all the complete the assignments and upload.